Alright, here's your help video for quiz 4.05. Okay, so to be successful in this quiz, you need to remember about the slope of parallel and perpendicular lines. Parallel lines have the same slope. And remember, slope is just the steepness of a line. So if two lines are parallel, they have the same steepness. So the slope's going to be the same. For perpendicular lines, they're opposite reciprocals. In other words, you have to change the sign and flip it. So that's a quick review of parallel and perpendicular slopes. You also need to be good with slope-intercept form, where m is the slope and b is the y-intercept. Alright, so let's try some problems. What is the slope of a line that is perpendicular to the line whose equation is this? Well, we can't just look at this equation and pick out the slope. It has to be in that slope-intercept form for us to be able to figure out what the slope is. So that's what I'm going to do. I'm going to take this equation and I'm going to convert it to slope-intercept form. In other words, I need to solve for y. I need to isolate y. So over here, if I wanted to isolate y, I would have to divide each side by 3. And when you do that, you divide each of these pieces by 3. So negative 4x over 3 plus 2 over 3. Okay, so now it is in slope-intercept form, and so now I can pick out the slope. The slope is negative 4/3. The slope is always the number that's attached to x when it's in slope-intercept form. So if my original slope is negative 4 over 3, and I want the perpendicular slope, remember perpendicular is the opposite reciprocal. So we have to change the sign and flip it. So we're going to change it from negative to positive, and then we're going to flip it. Instead of 4 over 3, it's going to be 3 over 4. So my perpendicular slope would be 3 over 4. Alright, line A is represented by this equation, y equals negative 2x plus 3. How do these equations compare to line A? So you want to decide whether they're parallel, perpendicular, or neither. Alright, so to figure that out, you have to find the slope. This original line is in slope-intercept form. So remember, the slope is the number attached to x. So my slope of the original is negative 2. Now for it to be parallel, it has to have the same slope. So I'm going to make myself a note up here that for parallel, it has to be the same. For perpendicular, it has to be the opposite reciprocal, meaning we have to change the sign from negative to positive, and we have to flip it. And flipping it is kind of confusing when you have a whole number. So let me just mention, there's always a 1 underneath a whole number. So if you flipped 2 over 1, it would become 1 over 2. And then neither just wouldn't be either of those. So let's check our answers. This one's already in slope-intercept form, and the slope is 2. Which means it's not negative 2 and it's not positive 1/2. That one is actually neither. Alright, this one's also in slope-intercept form and the slope is negative 2, which is the exact same as our original slope, so this one is parallel. And then this one's also in slope-intercept form and the slope is 1/2, so it is perpendicular. Alright. Write the equation of a line that passes through this point and is parallel to a line whose equation is this. Alright, so we got a couple things going on. First of all, we have a point. I'm going to go ahead and label that x and y. We want it to be parallel, so I'm going to make myself a note that I want the same slope. And then we have this equation. Unfortunately, I can't just look at this equation and pick out the slope because it's not in slope-intercept form yet. So the very first thing I need to do is I need to take this equation and I need to put it in slope-intercept form. That means I need to solve it for y. So I'm going to start off by minusing 2x from each side. Now be really careful here because 6 numbers and 2 x's are not like terms. And we want the x's to come first. So I'm going to put negative 2x first and then a positive 6 behind it. And then I still need to get this y by itself, so now I'm going to divide everything by -3. And now remember, you send that -3 to each of them. So -2 divided by -3 would be a +2/3. 6 divided by -3 would be a -2. Okay, so all of that work just to figure out that the slope of the original line was 2/3. That's really important for us though, because we want to write an equation that's parallel to that. So we needed to know the slope. And so now I know for my new line, the slope's going to be the same, so it's also going to be 2/3. And then my ultimate goal is to write an equation of a line. Remember, that's y equals mx plus b. That's the form that we usually use, the slope-intercept form. So I have some information. I have the m that I can plug in, and I also have an x and a y that I can plug in. So I'm going to go ahead and do that. I'm going to say -3 equals 2/3 times x plus b. And so now I'm going to solve it for b. So 2/3, let's see, 2 times, well, I'll do 2/3 times 9, or you could just do 2 times 9 and then divide it by 3, either way. So we get 6 plus b, -3 equals 6 plus b. We're still trying to solve for b, so we would need to subtract 6 from each side. And b would equal -9. So we've done a lot of work here, but we are finally ready to write our final answer. So we want the equation of a line. So y equals, our m is 2/3, so 2/3 x, plus our b is -9. So I guess I didn't really need the plus there. You could put plus -9, or you could just put -9. I kind of prefer -9, so I'm going to get rid of that plus sign. And that is the final equation for our new line. So let's just go over those steps again, because that was a lot. First, we took our original equation. We put it in slope-intercept form so we could find the original slope. Then we wanted the parallel slope, so we made a note that it was going to be the exact same slope. Then we need to plug it into the equation of a line. We know our x and our y from our point, so we plugged in our y and our x and our slope to solve for b. And then once we have the m and the b, we're golden. We can just write our final answer. All right, so let's try another one of those. What is the equation of a line? Sorry, my board just froze. Let's see. There we go. Equation of a line. So I'm going to go ahead and make myself a note that I'm looking for y equals mx plus b. That passes through this point. So I'm going to label that x and y. And is perpendicular. I'm going to make myself a note that I have to change the sign and flip it to this original equation. And the nice thing about this problem is this original equation is in slope-intercept form. The only thing that looks a little weird is we have an x on top, but remember there's really a 1 in front of that x. It's 1x. So you could rewrite this as 1/2 x plus 3, which I do prefer that you rewrite it, because then it's easier to tell that the slope is 1/2. The slope cannot be x over 2. You can't have a letter in the slope. All right, so my slope is 1/2. For my new line, I want the perpendicular slope. So I need to change the sign and make it negative, and I need to flip it. Now, -2/1 is the exact same thing as -2. So my new slope is going to be -2. All right. Now I'm going to go and I'm going to plug all my information in to the equation of a line. So I have my slope, my x, and my y. So I'm going to plug all that in. For y, let me rewrite this. For y, I'm going to plug in an 8. For m, I'm going to plug in a -2. And for x, I'm going to plug in a 1. We don't know the b value yet. That's actually what we're solving for in this step. So -2 times 1 is -2. We're trying to solve for b, so we need to get rid of that -2 by adding it to each side. And we have our b value equals 10. So we are finally ready to write our final answer. Now our final answer is going to be the equation of a line. We now know the slope is -2, and we know the b value is 10. So here we go. The slope is -2x plus 10. That is the equation of our line perpendicular to that original line passing through that point. Okay, last one. In this diagram, which equation could you prove to be true in order to conclude that the lines are parallel? All right. So you have to kind of think about parallel lines. Parallel lines have the same slope. And remember, when you're looking at a graph, the slope is rise over run. So if I wanted to find the slope of this top line, I would start here. I would rise up, count how many I rise up, and then I would count how many I run over. Well, it's kind of strange because we're given letters, but if you look, rising up is y values. So if we think about the y values, we go from 0 to b. That means I'm actually rising up b units. And then running over is x values. If I go from -a to 0, I've actually run over a units. So the slope of this first line, if I do rise over run, is b over a. All right? It doesn't really help me eliminate anything yet, though, because all of the first slopes are b over a. So now let's try to find the slope of the second line. All right, again, we're going to use rise over run. So for the rise, I need to look at the y values. So if I go from -c to 0, I'm rising up c units. Just like if you give it numbers, if you go from -2 to 0, you're rising up 2 units. It's the same thing, we're just using letters instead of numbers. And then we run over from 0 to d. Now let's just pretend d was a number. If we started at 0 and went over to 3, we'd be running over 3 units. So even though it's not a number, we can still see that we're running over d units. So the slope of the second one, the rise over run, would be c over d. And because we want them to be parallel, they have to have the same slope. So we have to be able to prove that the first slope, b over a, equals the second slope, c over d. They have to be equal for them to be parallel. So that would be our answer. Good luck on your quiz.